So chapter 7, section 2, I stole a picture from the book. That's what's up there on my thing. But it's powers of 10 in scientific notation. So powers of 10 in scientific notation. Scientific notation I found is not going to go away. That as you take high school math, high school science, it's going to be there. If you go on and do college science, it's going to be there. So I'd encourage you, if you're going to focus on something in this section, focus mostly on the scientific notation. Because if you learn it now, it's just going to make life better later on. So first thing is, I have this picture here, and I wouldn't frantically try to copy this down. What I'm really just trying to, as I was making my notes, I was looking at it, and as we have the 10 to the third, so here we have a 10 to the third. 10 to the third equals 1,000. 10 to the first equals 10. 10 squared equals 100. So we have all of those. What do you notice about the exponent and the number of zeros? If you have a 10 to the third, there are 3 zeros. 10 to the first, you have 1. 10 to the 0, you have 0 zeros. You just have the 1. So that's kind of what I wanted to quick grab from that. So Roman numeral 1 is going to be powers of 10. So powers of 10. And, if you know that, skip it. But I'm just going to say, write down a couple of those real fast. So 10 to the fourth is going to be 10,000. That I have 4 zeros there. If I were to have a 10 to the seventh, now I need to have 7 zeros. So I have a 1 and then 1, 2, 3, 4, 5, 6, 7 zeros. I was always taught if I had 5 or more digits, I should put commas in. So I'm going to ask that you do that. It just makes it a whole lot easier working with the numbers for me and for you. But 10 to the seventh then is going to end up being 10 million. And what you could do is kind of what they were showing in that last picture is if you have a 10 to the fourth, it's kind of like you have this, if the decimal point were there, you move it over 4 jumps. If you have the 10 to the seventh, you move the decimal point 7 places to the right for that from the 1. If I were to have a 10 to the negative 3, 10 to the negative 3, you could kind of look at it as though if you're starting with the decimal point there after the 1, like before, negatives mean you're going to move the jump to the left. So if I take and move 3 jumps to the left, that's what's going to give me this 10 to the negative 3. And I maybe lost you a little bit there, but we'll come back to it. So it ends up being 0.001. So with a negative exponent, we only have the 2. It's 1 fewer 0 in front of it. I'm trying to get myself into the habit of writing it like the book does. Oops. I was talking and trying to write at the same time. So 0.001. So I'm trying to get into that habit. But here's what I started talking about before and maybe kind of confused people a little bit. I'm going to say a 10 to the n power equals 1 period, then move the decimal n places. So move the decimal. I'm going to put n in quotation marks. N. You could do jumps. I'm going to say places. But you're going to move the decimal the same number of places as what the exponent is. And now, if we have a positive n, you move it right. So I'm going to say right, and put an arrow pointing to the right. If a positive n, and left, do my arrow to the left, if a negative n. And I'm going to try to put all that in a box to kind of show it's all together. And hey, look, it's important. But that's really, I'm trying to set us up to doing the scientific notation. That's why I'm kind of doing these powers in kind of like a weird, screwy way. So in other words, then, I'll do 2 quick examples, then we'll kick over to the scientific notation. So I'm going to say example, make that look a little nicer. So example, write as a power of 10. I'm going to do 2 examples. So my first one's going to be 1 million. So 1 million equals 10 to the sixth. And the easiest way is to kind of honestly ignore what I just wrote in red and just be like, well, there's 6 zeros. But the other way that you could look at it is though, well, my decimal point right now is right there when I have my 1 million. You could look at it as though, if I go with my little rule before, you could look at it as a 1 decimal point. Well, how many jumps does it take to get you from here to there? You have 1, 2, 3, 4, 5, 6 jumps. So it's 10 to the 6th. Fair enough? That doesn't help me a ton for the positive ones, quite honestly. But if I were to get something like this here, if I have 0.000, comma 0.1, so I also was taught 5 or more digits to the right of the decimal point, you should start putting in commas. In at least decimals, yes. And you always start counting at your decimal point. So I've had some people, when they put their commas in, they'll put a comma here, because they're starting here at the end. But instead you have to start at the decimal point and then count over 3 before you put your comma. All right, so for this here, my decimal point, you could look at it as though it started there. It ends up over here. How many jumps do you have? 5 jumps. So it's going to end up being 10 to the -5th because we jumped it to the left. I like being able to try to figure things out. Why do they work? That's how I can remember things. If you're just a memorizer, you could just remember when you have numbers like this. Let me quickly erase that a second. You could remember when you have numbers like this, numbers that are really close to 0, you're going to get a negative exponent if you're writing a scientific notation. Numbers that are really large like that, you're going to get a positive exponent. So that's one way you could just memorize it if you think that would be a better way for you to get it. All right, ready to jump to scientific notation? So here's really kind of the meat, and why I was teaching the first section will make a little more sense when we see this here. So scientific notation. My experience has been probably what will get you all the way through high school, and probably most of you then for life. Scientific notation, they want you to write it this way, that you'll have one number, then you'll have your decimal point, and then maybe you'll have other numbers after the decimal point. So I'm going to say like number, and then I'll put a little s in parentheses. But it could just be 5 times 10 to the 17th, or it could be 3.14 times 10 to the 4th. But typically they just have one number right there in front of the decimal point. In college physics, it's a little bit different, but most of you probably won't end up taking college physics, which is a shame because it's awesome. But, okay, all right. So number times number point, maybe other numbers, times 10 to a number. But this is the normal format that they want you to write it in. One number, decimal point, times 10 to some power. And let's actually go with this. All right, so my letter A, I'm going to say converting scientific notation to standard notation, or trying to take scientific notation to a normal number. So converting, actually maybe I'll just do scientific notation, arrow. You could write normal if you wanted to. I'm going to go with what they do and say standard notation, because that's the instructions that the book is going to give you. That's what I'm going to write on your test and so on. My first example then, I have 4.23 times 10 to the 5th. So 10 to the 5th, I'm going to go how many jumps? 5 left or right? Right, because it's a positive 5, I'm going to go 5 jumps to the right. So I'm going to actually just write my number down a little bit lower. It'll be a little bit less cluttered. But if I do 5 jumps to the right, do you agree it takes me 2 jumps just to get to the end of my number? The common mistake, people just throw 5 zeros on the end. But how many zeros are we going to put on the end? 3. Because 2 jumps get me to the end of the number, so I have 3 more jumps to go. My decimal point needs to go there. So I need to put in 3 zeros to kind of hold the place. So my final answer then is going to be 423,000. Does that make sense to people? Sometimes when people are starting, you'll see them do those little jump marks like I did. Once you get used to it, just kind of like, well, 2 jumps to get to the end, how many jumps left? Throw that many zeros on there. That's what I do when people aren't looking and I'm not trying to teach it. So second example, switch colors on you. So 3.14 times 10 to the negative 3. So how do we do that one? 3 jumps to the left. So if I'm starting here, I'm going to go 1, 2, 3 jumps left. So I end up with, I'm going to try to be a good boy and do like 0 point. How many zeros do I have before my 3? 2. So it took me 1 jump to get in front of the 3, and then I have 2 jumps left of my 3 jumps. So that'd be the answer to that one. Does that seem to make sense to people?
Yes.
Now I want to throw a little trick at you and see if any of you fall for it or if I've taught you well. So if I have a negative 3 times 10 to the 4th, what does that end up being? Or maybe I say this, how many jumps do I do? 4. Left or right?
Right.
Because
It's positive.
it's positive. It's a positive exponent. The 4 is positive. So I'm going to do 4 jumps to the right. How many zeros do I end up adding to it then? 4. Because I'm already at the end of my number right here, so I just can do 1, 2, 3, 4 jumps. So I end up adding 4 zeros here at the end. So my initial number is negative 3, so my final answer is going to be negative 30,000. Any questions on those? Seems like, we okay? Okay. And that? Then here's why. So I can see where people would be like, well, why in the world are we doing this? And I wouldn't write this down. But as you get into like the really cool math science stuff, you're going to start getting something like this. So if you have the mass of an electron, electrons are really, 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 really tiny, right? So they also have a very little mass. They don't weigh very much if you want to slaughter the units. So this is supposed to be like the mass. M is for mass. Electrons like the subscript. So it's in the mass of an electron. And again, I wouldn't write this, but this is the mass of an electron. 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, comma. Now I need to actually look at my book. 911. So I couldn't even fit it in a line. So if you're trying to like do this, it's just way more of a pain in the rear than just saying 9.11 times 10 to the negative 31. That the scientific notation becomes way, way, way nicer when you're dealing with very large. What's the mass of Jupiter? And you're trying to figure out how much it's going to pull some satellite off its path. Or what's the mass of the Earth? Trying to figure out the equation for gravity. How much force are you getting attracted to the Earth? And the very small masses of protons, neutrons, electrons, charges of those, and things like that. Good? So there is a point. You'll see the beauty, and you'll love it later on, maybe. All right, last thing, letter C. Comparing and ordering. So comparing and ordering. So if you want to look at a couple numbers in scientific notation and figure out which one's bigger, which one's smaller, or put these in order from smallest to largest, you could add this. I'm going to put it on here, positive only. When I first saw this, I was like, oh boy. Our book only does the positive. They'll hit you with like negative numbers perhaps later on in life. I like seeing steps. You can write them down. You can not write them down. But this is kind of what I thought I would do. I'd say list the numbers in order by powers of 10. So list numbers in order by powers of 10. In other words, which one has the biggest exponents and which one has the smallest exponents and things like that. Then the second thing is order numbers with the same power of 10. So order numbers with the same power of 10. In other words, if you have two of them that are both 10 to the third, then you figure out what's the order of those two 10 to the third ones. You're welcome to kind of do it in fewer steps if your brain can keep track of them all. So one example, and then we are done for the day. So I'm going to say put in order these numbers here. I'm going to try to squeeze them all in one row. But I have 1.3 times 10 to the negative 3. And I have 6.3 times 10 to the negative 3. And I have 4.1 times 10 to the 6th. And 2.1 times 10 to the negative 2. And one more, 5.4 times 10 to the negative 3. So first thing I'm going to do is try to write them in order by the exponents. And I was a little bit of a punk because I have... So you could, if you wanted to, go through and rewrite them all just with the powers of 10 and then go back and do that second one. I'm going to try to combine them into one step, so I think that's what you're going to do. But do you agree I have all three of these are a 10 to the negative 3? So if we're looking at those, and I don't know if I do this first step, but do you agree that that first one, do you agree that's going to be 0.0013? That 10 to the negative 3, I move my decimal point 3 to the left. My next one, I move my decimal point 3 to the left and I get 0.0063. Which one is smaller? The 1,3 is smaller, right? It's closer to 0. So we know that so far this one's kind of in first place, this one's in second. Now how about this guy over here? Is this one in the middle of those two, or is it going to be left, right? Middle. Because just like the 1.3, so this here was smaller than this with the same exponent. Do you agree the 5.4 times 10 to the negative 3 would fit right in between? Because the 5.4 is between the 1.3 and the 6.3? Yep. So then in writing those, so I have, so this is going to be my first one. Actually, maybe this would be helpful. So we know that this one is going to be number 1. This one is going to be second, we said. This is going to be third. My next smallest is going to be the 2.1 because we have a negative 2 next. And then last but not least, we'd have this with a positive exponent, the really big number. So to write them out then, you could skip writing if you want to just number them like that. But on the test, on the quiz, we'll be looking for something like this here. 1.3 times 10 to the negative 3, comma, 5.4 times 10 to the negative 3, and then 6.3 times 10 to the negative 3, then 2.1 times 10 to the negative 2, and 4.1 times 10 to the 6. Do you feel like you have enough to go on for those? Don't need another example?